You hate angle of depression and elevation?
I hate you too.
So, we are going to study today angle of depression and elevation. It's not as scary as it sounds. It might not even sound scary to you. So, on your notes page, you've got a boat and you've got a lighthouse. So, what I need you to do is pretend that you are hanging out in the boat and you are looking up to the lighthouse. So, I want you to draw your line of sight. So, draw a dotted line from the boat to the lighthouse. That is called, Austin, your line of sight. That is you staring at the lighthouse. Draw a dotted line from the boat to the lighthouse. Angle of elevation, that's the one we're doing first. This one first. Angle of elevation, looking up.
I don't know where.
This is looking down.
Oh, I guess we're doing it. Was there an angle of... Huh. That's weird. Okay. Well, we're going to do, I don't know where the slide went. We're going to do angle of elevation first. And the slide is missing from my slides. So we'll pretend that this says elevation. We're doing elevation first. Okay, so angle of elevation is when you are looking up. You're elevated. When you hear the word elevate, it makes you think up. Like if someone says, like if your leg is hurt and someone says to elevate your leg, what are they saying? To prop it up, right? Elevate. Elevate means up. So you are standing, you're on the ground, and you are looking up. That is the angle of elevation. And it's always formed with a horizontal line. Show me with your arm, which way is horizontal? Which way? The horizon, guys, the horizon. It's this way.
Oh.
Yeah, that's, what's this called, Julius? What's this called?
Vertical.
Vertical. So it's always formed with a horizontal line. So draw yourself a horizontal line. Dimitri, pick a number, an angle number. A number that's an angle. Just pick a number that would be an angle, huh? 7. Okay, so that angle of elevation today is going to be a 7-degree angle. So put 7 degrees. That is the angle of elevation. Okay. That's all we're going to do on that. Now, let's do the angle of depression. I'm going to erase this since I have to use the same slide twice. So that's the angle of elevation. Now, guys, we're not in the boat anymore. Where are we now?
Lighthouse.
We're in the lighthouse. So the angle of depression is when you're high up and you're looking down. You're depressed. You're down. Oh, so sad. So you're going to draw the same line, but this time you're in the lighthouse looking down. And this angle is also formed with a horizontal, so you need to draw in a horizontal. So the angle of depression is that angle formed by the horizontal way up high and you looking down, down, down at the boat. So that's someone at the lighthouse who spies the boat coming into the harbor. Where is the angle of depression? Where do I put the angle? It goes right here. That is the angle of depression. So make sure you put 7 degrees because the most commonly missed thing, I'm going to write this, but then I'm going to erase it because I don't want you to ever do it. The most commonly missed thing is to put the angle of depression right there where the blue 7 is. That one is not the angle of depression because that's formed with a vertical line. They're never formed with vertical lines. They're always formed with horizontal lines. Okay? Now, something cool about, oh, there's a picture missing here. Awesome. Something cool about the angle of elevation and the angle of depression is, let me draw those back in. There's your picture missing from my lesson for some reason. Something cool about this angle right here and this angle right here is that they are congruent. Why? What kind of angles are they? Give me a vocab word. Not vertical.
I know what it is.
Not corresponding.
I give up. No way.
Almost. You're halfway. Opposite is not the right word. Alternate interior. Ding, ding, ding. Because they are alternate interior angles. So write it down. The angle of elevation is congruent to the angle of depression because they are alternate interior angles. Guys, this is great news. They're congruent. They're always the same number. So if the angle of depression is 28, guess what? The angle of elevation is also 28. You're done. You don't have to change the number. That's awesome. They're always the same number. We can't get confused because they're always the same number. So that's great news for us. Okay, what I want you to do is you've got 4 examples. All of these examples are going to involve a right triangle. So what I want you to do first is draw 4 right triangles. Draw one for number 1, number 2, number 3, and number 4. Draw me 4 right triangles. Empty right triangles.
With the box, right?
With a box, yes. Definitely put a box because all right triangles need to have a right angle. So you're drawing 4 right angles, 4 right triangles.
Wait.
They can be situated either way. So mine is situated like this, but yours might look the other way. And that's perfectly fine if yours is like this. Instead of making our problem look like a right triangle, we're going to make this right triangle look like our problem. So every time from now on that you're given a word problem, what do I expect you to do first? Draw what?
Triangle.
Just draw a right triangle. Don't try to draw a picture of the word problem because it's easy to get confused about, wait, where's the tree and where's the shadow and where's the bird and where's the hot air balloon? It's easy to get confused. So if you just draw a right triangle, you can make that fit your word problem. Let's do it. Should I pick on you, Austin? Austin, read number 1 out loud.
The angle of elevation from point A to the top of the cliff is 34 degrees. If point A is 1,000 feet from the base of the cliff, how high is the cliff?
Awesome. Okay, Nasia, I'm going to have you come to the board and put 34 in the picture and put 1,000 in the picture. Where it goes. Do you want to use this triangle or this triangle? Whichever one. Pick one. Everyone else should be putting those numbers in your right triangle that you drew. You should be putting those numbers in your right triangle. The angle of elevation is 34. That is perfect. And point A is 1,000 feet from the base of the cliff. Yeah. Awesome. Thank you, Nasia. That's exactly it. So, we are making our triangle fit the picture. She chose to use that triangle, so I'm going to erase the other one so we don't get confused. So this means that's got to be point A, and this has got to be our cliff. That's our cliff. So someone's standing 1,000 feet away from a cliff. They're standing at point A, and when they look at the top of the cliff, it's 34-degree angle to the top of the cliff. How high is the cliff? So Ava, where does X go? Would X go here or here? A or B? B, very good. There's X. Ashley, what trig function do you want to use? Sine, cosine, or tan?
Tan.
Very good. So everyone write tan. Let's write our empty template. I'll give you a hint. With word problems, tan is the most used trig function with word problems. Because in real life, we usually know the ground. We usually know the height. We don't usually know this diagonal distance in real life. I'm just letting you know that tan is the most often used. Okay, who have I not picked on today? Who have I not picked on? Brett, I haven't picked on. Oh, Alea? Okay, Alea, fill it in. What do I put here in parentheses? Torin pointed to you, by the way. What goes here? 34. And what goes here? Opposite over adjacent. Was that Dimitri?
Yes.
Dimitri. Good job. All right, let's solve it. Everybody solve it. Kendall, solve it. What do you get? Kendall, come on. Head up. Austin. You're already done. What'd you get? Tell me. Huh? Oh, man. Omar, what'd you get? Are you done? Did you plug in your calculator? Where's your calculator? How can you not have a calculator? Go get a calculator. Oh,
Dude.
how can you not have a calculator?
But it
We're
was
doing
so
tricks.
fast.
Done.
Kendall, how tall is that cliff? I just can't wait to find out. Mode check, Julius. Mode check.
174.
If you get a negative answer, you're in the wrong mode. What? 674?
0.5.
Oh. 674.5 feet tall. That is how tall our cliff is. Nice tall cliff. Don't stand at the edge of that thing. Can we do the next problem?
Why not?
I'm not really asking for permission. Go do the next problem.
There's the.
I'm actually going to erase this. Will it let me erase you? Go away. Go away. Go away. No.
Where's their delete?
I know.
Or not? Oh, okay.
Have you read the problem? Should have by now. Jen's going to read it out loud for us.
The angle of compulsion from the top of the foot on the ground according to the base. How far is the foot? It's a foot of the
Thank you. Okay, now here's the deal. I need everyone to listen. I already said that the angle of depression is congruent to the angle of elevation. So what I recommend is every time you're given an angle, I don't care if it's elevation or depression, I don't care which one it is. Every time you're given an angle, I want you to put it on the ground. Every time. I know that's the angle of elevation. I know I'm putting it there. But the other choice would be to put it up here, 42, hanging out outside the triangle, and I don't recommend that. That is confusing. So I do recommend every time you're handed an angle that you put it at the bottom every single time, no matter what, it goes at the bottom. Okay, let's find out where our other stuff goes. An 80-foot building. Well, they're always congruent, Ashley. And so, since this one matches this one, I'm just going to choose to put it here because this one's inside my triangle, whereas this one, he's outside my triangle. I don't want to use that one. Okay, it's an 80-foot building. Where should I put the 80? Yep, it's the building. Put it right there. And the angle, how far is the foot of the building from point A? So here's the foot of the building. Here's our point A. So we want to know how far away that person is if they're looking at the top of the building. Surprise, surprise, which trig function are we going to use? It's tan again. It won't always be tan, but it will most of the time. Julius, you already got the answer? John, what goes in parentheses right here?
42.
42. And what goes here? Opposite over adjacent.
80 over.
Awesome. 80 over x. Paige, where's x? Numerator or denominator? Where's x? Denominator. So everyone needs to divide. Denominator, divide. 80 divided by tan 42. Let's see, what do you get? 88?
89.
88 point what?
8.
88.8 feet away from the building. So that person's standing 80 feet away from the building. 88.8 feet away from the building. 80 divided by tan 42. You're doing great. 2 down, 2 to go. Dimitri, read this one. Yep, read it. Yep. Mister. A blimp. Come on, a blimp. Brett, read it.
The blimp hovers over a stadium at an altitude of 125 meters. The pilot sights a tennis court at an angle of depression of 10 degrees. Find the distance between the tennis court and the stadium.
Thank you. Shelby, where should I put the 125? A blimp hovers 125 meters over a stadium. Vertical. Very good. Very good. 125. That's where it goes. Megan, where should I put the 10-degree angle?
In the bottom.
On the ground. Yep. Bottom. Very good. It goes on the ground every time. On the ground, on the ground, on the ground. And then what are we trying to find? Here's a stadium, by the way. I'm going to put S for stadium. Here's T. That's the tennis court. Where should I put X? Between the stadium and the tennis court, right? How far apart are they? Oh my goodness, what are we going to use?
Yeah.
Tan again. Kenneth, are you going to do this one? Kenneth, are you gone for the day? Oh, it is Tanton. I did not do that on purpose, I really promise. Omar, multiply or divide? Denominator divide. Awesome. 125 divided by Tanton. Divided by me. Matt, what do you get? 708.9 what units? Meters. That's how far away the stadium is from the tennis court. Last problem. Yay. Okay, read it yourself. Draw the picture yourself. You already have the triangle. And label the picture, and I'm going to walk around and look at them. See some good labeling. Your X is in the wrong spot. Your X is in the wrong spot. You don't have an X yet? Yes, Kendall? You're trying to find how long the ladder is. Did the ladder fall to the ground? Nope. Good job. That might help you a little bit. There's a ladder leaning against a house. Yes, very good. The angle always goes on the ground. There's the angle. It's on the ground every time, always. The house is 18 feet, so the vertical is 18. And then you're looking for the hypotenuse. You're looking for the ladder. You're looking for the hypotenuse. You're looking for the ladder, yeah, right? How long is the ladder? Yeah. Ava, sine, cosine, or tan? Opposite hypotenuse. Very good. Sine. Sine 62 equals opposite over hypotenuse. Torin, multiply or divide? Denominator divide. Very good. Catherine, tell me what you get.
I got
20.3 feet long. Let's just do 20. Because when they, to the nearest foot. Huh. Yep, 20. Nearest foot. So it's a 20-foot ladder. That's a long ladder. Those are your notes. You have no homework tonight. I will see you tomorrow, and you'll be ready to practice more word problems.